Right, now that we have that discussed, we added our dropout. We discussed why it is important in order to avoid overfitting. Let's now put everything together into a causal self-attention class. So here we are going to add something else. We're just going to add the batch so that we can do batching. We can train in batches because training in batches makes the performance usually makes the performance much better. So that's what we are just doing here. And this is the class that we're creating, our causal attention class. As we can see, this is our D out, our dimension out. And then we have our dropout. We have our WQ, WK, WV, and our dropout. That's what we created here. We're using dropout from Torch. Nice. That's it. And this is sort of like similar to what we have, what you had previously, but we are adding a few things like the masks and all of that and dropout. But it's sort of similar to what we had when we did that self attention with trainable weights. Now we are just adding our mask and adding our dropout. So here we calculate our KQVs. After calculating our KQVs, we calculate our scores, attention scores. When we calculate here, we the if you read the codes, because we can't really go through each and every line, but when you read the codes themselves, what you will end up seeing is we we are now changing the way we are calculating our transpose, because there we're not dealing with batches and all of that, but now we have added another dimension. We have added a batch dimension. So here we are trying to that's what we're trying to that's what we're trying to then transpose. We're transposing on the two dimensions and not the batch dimension, because now we have three dimensions. We have our batch dimensions, the number of tokens in each input, and then the dimension of each token. Because remember, the dimension could be anything, could be 738. Our dimension in our examples was 3. You can read the codes themselves. You remember, this query is just D in, D out. That's what we had. But now we just have dimension, because our X that is coming in, the X that is coming in now is a batch. It now is a batch. So that's why we have a B. I said dimension, but actually meant batch. Batch. And each input, how many tokens are in each input, and what is the embedding size of each input. Pretty much that. So that's why we're transposing over the 1, 2. We're transposing over the 1, 2 dimensions and not the B dimension, but that's just it. And then we create our mask. We do our attention scores. We mask fill. And then after mask filling our attention scores, we then calculate our attention weights using the soft marks. You remember our attention scores, when we apply the soft marks, each row then gets added up to 1. And because we have our minus infinity in our attention scores, the minus infinity, those ones, they go up to 0. They go down. Oh, yeah, minus infinity, they go up to 0. Technically speaking, mathematically, but let's just say they are converted to 0. They're converted to 0 with the soft marks. So it does two things: adds the rows up to 1, and also the infinity goes to 0. So now we have our proper attention weights. When we have our attention weights, we then apply dropout. We apply our dropout, and the dropout that we created our dropout here, and our dropout we'll put whatever we're going to, it might be 0.5, it might be 0.3, 0.1, whatever it's going to be. That ratio that we are going to use, it will be there. So our attention weights are just dropped out, and now we've masked attention weights with dropout. That's what we have in here now. And then from there, we then calculate our context vectors. We then just say attention weights matrix multiplied with the value vectors that we would have created from KQV here, done. And then we just return those context vectors. So this is now just applying that causal attention with dropout. We have our D in, D out, context length. We create our object, the causal attention object. And here we just apply it to a batch. So this is printing our our context vector. So these are our context vectors from causal attention with dropout. That's pretty much what we wanted to do. We wanted to create this. We wanted to create this function here. We wanted to create this class. I mean, we wanted to create the causal attention class that brings everything together. You can take when you get the codes, read them line by line. Read them line by line, and it makes sense. And think about what we have discussed already. This is just applying what we have discussed already, straightforward like that. And this is the cause of for the first batch, and this is the cause of context vector actually, context vector for the second batch. That's all we have there. Brilliant. Not that this dropout I emphasize that it is applied only during training and not at any other time. It's just applied not at inference. And inference we do bring back those ones that we would have ignored. So now we've done the third part, the third type of self-attention. We first started with a very simplified one that had no training weights. Then we moved on to self-attention with training weights. That's where we introduced our KQV matrices. But the problem with that is the we hadn't masked anything, which means even future tokens were being seen. So we moved to causal or masked attention, where we masked the future tokens at that particular stage, so that the tokens can only know what has happened before and what the current one. Now we're just going to move to multi-head, and everything will then connect. So in the next video, let's discuss multi-head attention.